Like terms.
Today our learning intentions are to remember what terms are, to be able to identify like terms within an expression, and to be able to simplify expressions by combining like terms. We will know we are successful when we can decide whether or not two terms are like terms, and when we can simplify like terms. When we add or subtract pronumerals in algebra, it's called simplifying. This is because our expression kind of looks more simple after we've done it. We can simplify expressions. We can do it for equations, but really when we're simplifying equations, all we're doing is simplifying the two expressions on either side of the equal sign. Let's do this one as a quick example. Let's say I had the expression m plus m plus m plus m plus m. I can simplify this by adding the m's together to be 5m. That's because I have 5 m's. If you think about it kind of with numbers, let's pretend that m equals 5. So that would be 5 plus 5 plus 5 plus 5 plus 5. Now we know when we add the same thing over and over again, it's the same as multiplying. So I would say the number 5 times 5 times is the same as 5 times 5, which in this example is the same as 5m, because 5 times m would be 5 times 5. So you can see that if we're adding the same thing over and over again, it's exactly the same as just multiplying it. That's why we can group them all together. So we're not actually changing the expression. M plus m plus m plus m plus m is still the same as 5m. We've just grouped them together, added them together to make it more simple. Now we have this new word called like terms, and like meaning similar to each other. And on the flip side, we have non-like terms, meaning not similar to each other. This basically means that we can only add or subtract pronumerals that are exactly the same, that are like each other. And we can kind of tell this from the example we just did. Let's say we have the numbers 5 plus 5 plus 5 plus 5 plus 3. We couldn't say then that that's the same as 5 times 5 because we don't have 5 5s. We could say it's 4 times 5 plus a little 3 left over. So we can only ever add those things up if they were exactly the same. Let's think of it like apples and oranges. Let's say my apple is an A and my orange is an O, and I've got 1 apple and I've got 6 oranges. Can I say that I've got 7 apples? No. Can I say that I've got 7 oranges? No. Can I say I've got 7 apples and oranges? No. So I couldn't write it as 7A, I could not write it as 7O, and I definitely couldn't write it as 7AO, because that would be 7 times A times O. So this means that when I have an A and an O by themselves, I cannot add or subtract them because they are not like terms. We can only ever add and subtract pronumerals that are exactly the same. Now when I say exactly the same, I mean like exactly the same. So x and x, or x and 2x, they are like terms because they both have the same letter. So if I look at that, if I was going to add them, I've got an x and I've got 2 x's, so that's 3 altogether. And if you're wondering, remember I had that invisible math of a 1 in front of there. But x squared plus 2x, they are not the same. They are not like terms because my pronumerals are actually different. On my left-hand side here, my x is being squared. And over here on the right-hand side, it's just a plain old x. So they're not the same and I can't simplify them. So when we are trying to simplify pronumerals, they have to be exactly the same. So if I had AB, I would also need to have AB on this side. But if I had A squared B and I had 2AB squared, they are not even the same because on this side, the A is being squared and on this side, the B is being squared. So I just really want to remind you, you can only ever add it if it's exactly the same. Both of them are exactly the same. If they're not, if they're a little bit different, like the ones I've showed you here, we have to keep them separate. And that's fine. In this sort of examples, we're going to have those long sentences, those expressions as our answer. We're not trying to figure out one number as the solution. We're just trying to take an expression and make it a little bit more simple. But if the pronumerals are different, we have to leave them separate. There's only one time when it can be a little bit like we're breaking the rule. Let's say I had AB plus 2BA. I can actually simplify that because the pronumerals are actually the same. I've got an A just by itself and a B just by itself, and over here I've got an A by itself and a B by itself. Yes, they're in the wrong order, but we know that we can multiply in any order. For example, 2 times 7 equals 14, and 7 times 2 equals 14. So changing the order of a multiplication doesn't change the answer. So this means the only exception to the rule is that our letters can be in the wrong order, except it still has to be the same letters. So I can't do AB and BAC. These are not like terms because even though I've got two of the letters the same in the wrong order, I've suddenly got a C in the second one. So I can't do that. So if our letters are exactly the same or in a little bit of the different order, then we can add them together. Now this is also the reason why I've told you many times to put your letters in alphabetical order. This just makes it easier because if you're writing them in alphabetical order, you can easily see if the letters are the same. The other thing I really want you to remember is that our plus and minus sign always follows the term behind it. So if I have 2x plus 3y, take 9ab, take x. This plus is with this 3y, this minus is with the 9b, and this minus is with the x. That's really important because if I was going to simplify here, the first thing I have to do is find some letters that are the same. And I find x and x over here. And then what I have to do is smush them together. And to do that, I'm going to go 2x, take away x, and 2x, take away an x, just leaves me with 1x left over. But that's really important because if I had missed that little minus, I might have added an x, and then I would have made it bigger when it should have been smaller. So we need to make sure that the signs are always following behind to the term behind it.